Hello students, welcome back. I'm Rinkesh sir, and today we'll start with a new chapter, that is chapter number 10, Straight Lines. Before starting the exercise, let's see some basic concepts and formulas related to straight line. First, let's revise some formulas that you have already studied in standard 10. The first one is distance between 2 points. Distance between 2 points P x1 y1 and Q x2 y2. Okay, so the distance PQ will be equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, see if 2 points are given such that a 3 minus 5 and b minus 1 2, then the distance AB will be equal to under root of 3 minus minus 1, that is 3 plus 1 whole square plus minus 5 minus 2 whole square. Just a minute. Okay, so 3 plus 1, that is 4, 4 square, 16 minus 5 minus 2, that is minus 7 square, 49. So this will be equal to root of 65. Okay, so distance AB is root 65. So this is the first formula that we are revising, that you are studying in chapter that you are studying in standard 10. Okay, so note it down. Okay, now let's see next. Next, the coordinates of the point dividing the line segment into two in the ratio m is to n. Coordinates of point T, that is xy, dividing the line segment AB with ratio m is to n, where A point A is having coordinate x1 y1 and B x2 y2. Okay, so this will be P x y, that will be equal to mx2 minus mx1 upon m, sorry, it's my mistake, minus nx1 upon m plus n, and sorry, it's not minus, it's plus my2 plus ny1 upon m plus n. Okay, so these are the coordinates of a point which divides the line segment in the ratio m is to n. Okay, and this dividing the line segment internally, remember this is internally, the ratio m is to n will be positive. Further, in this chapter, we will see when the what happens when the point divides the line segment external. Okay, so first note down this formula. Let's see the next. Next is midpoint of line segment. Midpoint PXY of line segment AB, where A x1 y1 and B x2 y2. At that place, the coordinates of P will be x1 plus x2 by 2 and y1 plus y2 by 2. So these are the coordinates of midpoint. Here, so note down this formula. Let's see the next. The next is area of triangle with vertices A, B and C. Area of triangle ABC with vertices A x1 y1, B x2 y2 and C x3 y3. So in this case, the area A will be equal to half into modulus of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So it's modulus of x1 into y2 minus y3 plus x2 into y2 minus y1 plus x3 into y1 minus y2. This is the formula for area of triangle ABC with vertices A x1 y1, B x2 y2 and C x3 y3. So note down this formula. Now let's see some new concepts. First is slope of a line. Okay, so there are three different ways in which you can find a slope. First, if the angle between the line and positive x-axis is given. Now see, if you draw a line in this way, okay, and if this angle is theta, means it is making angle theta with positive x-axis. Then if it's negative, it is making angle 180 minus theta. So the first formula is using the angle it makes with positive x-axis. M will be equal to tan theta. Where what is theta? The angle made by the line with positive x-axis. If I want to take 180 degree minus theta, okay, 180 degree minus theta, then I can also write down m equal to minus tan 180 degree minus theta, right? So I can also find out in this way, just for example, where this formula will be useful. Okay, if the line is in this direction, okay, now if I want to take this angle as theta, then here the slope will be minus tan theta. Means tan theta, if theta is making angle with the positive x-axis, and minus tan theta if theta is making angle, sorry, if theta is the angle made with negative x-axis. Okay, so just for example, this is the line, and if this angle is 45 degree, that means this will be 135 degree. So in this case the slope m will be equal to tan 45 degree equal to 1. But if this is the case, And if this is 45 degree, okay, and this is 135. So here slope will be minus 10. Angle 45 is with negative x-axis. So this will be equal to minus 1. I can also use 135 with positive x-axis, that will be 10 135. So that will be 10 90 plus 45, 90 degree shift, it will be cot 45. In second quadrant it will be minus, so again it's minus 1. See, so in both the case the answer will be same. Okay, so this is the first form that you can find out the slope. If theta is the angle it is making with positive x-axis, then m is equal to tan theta. If it is angle made with negative x-axis, then it will be minus tan theta. Okay, so this is the first thing, the first part, how you can find out the slope. So just note this down. Now second, if 2 points are given, okay, slope of a line when 2 points are given, slope of a line when 2 points p x1 y1 and q x2 y2 are given. Okay, means in this case this is a line, 2 points are given, this is point P and this is point Q, means x1 y1 x2 y2. So in this case the slope will be equal to y2 minus y1 upon x2 minus x1. Clear? So this is the second way in which you can find out the slope. If 2 points are given, then we will use this formula. If the angle is given, then we will use the first formula, that is tan theta. Okay, this is the second way. Just note it down. Now let's see the third way. When the general equation of line is given. Okay, the third way, when the general equation of the line is given. When the general equation of line, that is ax plus by plus c equal to 0 is given. Okay, in that case the slope m will be equal to minus a by b. Okay, so this is about the third part. See, ax plus by plus c equal to 0 is the general equation of a straight line. So in that case you can find out the slope m is equal to minus a by b. Okay, so this is the third way. So just note it down. Now let's see some examples. First, for the second part, see if point P is 3 5 and Q is minus 2 1, then the slope of PQ, this will be equal to y2 minus y1 upon x2 minus x1. So this is x1, this is y1, minus 2 x2 1 y1, sorry y2. So this will be 1 minus 5 upon minus 2 minus x1, that is 3. So this will be equal to minus 4 upon minus 5. So the slope in this case is 4 by 5. Okay, this is the example when 2 points are given. Now for the third, if equation of line is 3x minus 4y plus 2 equal to 0. So here a, this is a, that is equal to 3, b, this is b, that is equal to minus 4, and c is equal to 2. So in this case the slope will be equal to minus a by b, that is minus 3 upon minus 4 That implies the slope will be equal to 3 by 4. Okay, so this was the example when general equation of line is given. Okay, now one more important point. See, if you see a line bending towards positive x-axis, then in this case the slope is positive. Okay, but if the line is bending towards negative x-axis, in this case slope is less than 0. If the line is vertical, okay, if the given line is vertical, this is x and y axis, then in that case m is undefined, slope is undefined, because this will be the 90 and tan 90 is undefined. And if the slope, if the line is horizontal, in that case the slope m is equal to 0, because the angle it is making is 0, so tan 0 is 0. Okay, so note down these three important points regarding the slope: when slope will be positive, when slope will be negative, when it will be 0, when it will be undefined. Okay, now let's see the next conditions between two parallel lines and perpendicular lines, or the slopes of two parallel lines and slopes of two perpendicular lines. First, if L1 is parallel to L2. Okay, now let's draw two lines. Okay, L1 and L2. Now see, as both the lines are parallel, this angle will be theta and beta. So here theta will be equal to beta, right? Because both are parallel. That means tan theta will be equal to tan beta. And what is tan theta? That is the slope. So m1 will be equal to m2. Okay. So this is the condition for parallel lines. So if slope of two lines are same, that means both are the parallel lines. Or if two lines L1 and L2 are parallel, that means the slope of both the lines will be same. Okay. Now for perpendicular line, conditions for perpendicular line. Perpendicular lines. Okay, means if L1 is perpendicular to L2. Okay, means the case is like this, and it's making an angle 90 degree. So let this will be alpha and this will be beta, and this is 90. Okay, now we know that the exterior angle is sum of two interior angle. So this is 90 and this is alpha. So beta will be equal to 90 plus alpha. Okay, so let's say this is L1 and this is L2. What will be slope of L1? That is tan alpha. What will be slope of M2? Tan beta. That will be equal to tan. What is beta? 90 degree plus alpha. So 90 degree shift, it will be cot alpha, and as 90 plus second quadrant, it will be minus. So this is minus 1 by tan alpha. So what does this show? M2 equal to minus 1 by what is tan alpha? M1. That implies M1 M2 is equal to minus 1. So two lines are perpendicular if the product of their slopes is equal to minus 1. Okay, so this is the condition for perpendicular lines. Now let's see one more. The last of day, that is angle between two lines. Angle between two lines. Okay. Now see, if I draw two lines, okay, then there are four angles. One, two, and the vertical opposite three and four. Okay, so from that 1 and 3 are same and 2 and 4 are same. So there is we will consider one as acute angle and one as obtuse angle. So the acute angle is called the angle between two lines. Acute angle is the angle between two lines. In this case, alpha. This will be the angle between two lines. Now let's say the slope. These are line L1 and L2. If the slope of L1 and L2 are M1 and M2, then angle alpha between both the lines, that is L1 and L2, will be given as tan theta is equal to modulus of m2 minus m1 upon 1 plus m1 m2. Okay, here we are taking modulus because if you take modulus, then you have to take positive value, and that positive value will give the acute angle. Sorry, here we have taken angle alpha, so I write down tan alpha. If alpha is the angle between two lines having slope m1 and m2, then tan alpha will be equal to m2 minus m1 upon 1 plus m1 m2 in modulus. Okay. Okay, students. So that's it for today. Thank you.